Hi there, Mr. Miah here, and in this tutorial we'll be going over 5 questions on algebraic fractions that should help you with your exam prep. So when you are simplifying algebraic fractions, the aim of the game is to factorize the numerator and denominator fully and then just cancel out any like terms in the numerator or denominator. Okay, I say like terms, they need to be identical. Let's just split this up into numerator and denominator. So let's take the numerator as a and the denominator as b. So if we take a, so that's 3x squared minus 17x plus 10, and we factorize this fully. Well, we're going to have to do the AC method, so we need to find two factors of 30 that are going to add to give us negative 17 there. Please let me know if you want a tutorial on the AC method. I'm assuming your teachers have taught you, or I have. So if we have 30, well, the factors that can make 17, the only ones I can think of are 15 and 2. So that should work. In order to get a positive number, we multiply, but a negative number, when we add, it must mean that it's negative 15 and negative 2. So we are going to split up 17x or negative 17x into negative 15x and then negative 2x, and then the plus 10 comes down and just forms that split down the middle. And we're going to factorize. So the first bracket is going to be 3x, x minus 5. The x minus 5 should repeat, but we'll just double check it does. Minus 2x and 10, I can factorize out a negative 2. And then inside, I should have x minus 5. Yes, that works. So I'm going to bring the 3x and minus 2 together. 3x minus 2 as one bracket. The second bracket is x minus 5. And we're going to stop there with the numerator. And we'll do the same to the denominator. So I'll just write it here. So this is b. So this is the denominator we're talking about. Let's just label this as a. We've got x squared minus 7x plus 10. We need two numbers that multiply to give us 10, but they need to add to give us negative 7. In this case, it's got to be 5 and 2. Both are going to be negative. That means my bracket is going to be x minus 5 and x minus 2. Now I'm going to write a over b. So it's going to be, let's do it up here, 3x minus 2, brackets x minus 5, all over x minus 5 and x minus 2. Hopefully at this point you can see that both the numerator and denominator have x minus 5, so I'm going to cancel them out. Why does my pen keep getting thinner? Okay, I don't know if you can see that I'm cancelling out the x minus 5, and I am left with 3x minus 2 over x minus 2. And you can stop there. Okay, in this question, we are going to solve 2 over x plus 3 plus 9 over x plus 7 is equal to 1. When it says solve, we are just looking for x values that will satisfy this equation. So the first thing we're going to do is we are going to get rid of all the denominators. So to get rid of the first denominator, I have to multiply all of the terms by x plus 3. And that includes the 1 at the end there. And to get rid of the second denominator, I am going to multiply all of the terms by x plus 7. Hopefully you can see that the first fraction, the x plus 3 will cancel, and I'm going to be left with 2 brackets x plus 7. In the second fraction, I will cancel out the x plus 7s, and I'm left with plus 9 brackets x plus 3. And then I've just got 1 times x plus 3 times x plus 7, so I can get rid of the 1 and just leave it as x plus 3, x plus 7. Now you might be thinking, why is it that I need to multiply all of the terms by that denominator? Well, I'll show you a question. 1 plus 2, hopefully you know the answer is 3. If I was to multiply one of these terms by 2, so let's take the first one, I would be left with 2 plus 2 is equal to 3. This statement is obviously incorrect. So if I multiply the 2 by 2 and I multiply the 3 by 2, now the statement will read as 2 times 2, which is 4, and 3 times 2, which is 6. this statement is now true. So we follow that same principle when we are cancelling out denominators. If you're multiplying one of the terms by x plus 1, for example, you have to multiply every single term in that equation by x plus 1 so that it retains its value. Coming back to the question, I can now simply expand and simplify. So if I take 2 brackets x plus 7, that becomes 2x plus 14. Then if I expand 9x plus 3, it's going to be 9x plus 27 is equal to, so I'm going to use the expansion of single bracket method. So I've just got x, I'm going to multiply that by x plus 7. So it ends up being x brackets x plus 7. Then I'm going to take the positive 3 and multiply that by x plus 7. And I'll write my answer below. X times x is x squared. X times 7 is plus 7x. Then I've got positive 3 times x is positive 3x. Positive 3 times 7 is positive 21. At this point, I'm just going to tidy everything up and gather like terms, simplify. So I've got 2x plus 9x is 11x. 14 plus 27 is 41. And that's equal to x squared plus 10x plus 21. Now at this point, I'm just going to gather like terms again, and I'm going to get rid of the 11x on this side, so I'm going to minus 11x here, and I'm going to minus 11x here. And now I'm going to minus 41 on this side, and minus 41 on this side. So you should notice on the left hand side, I'm just going to be left with 0. X squared stays the same. 10x minus 11x is minus x. 21 take away 41 is minus 20. At this point, I need two numbers that will multiply to give me negative 20, but add to give me negative 1. The numbers that will satisfy that will be 5 and 4. I need these to multiply to give me a negative number, so I know one of them must be negative, and I'm trying to add them to give me negative 1. So that must mean negative 5 plus 4. So in my brackets, it's simply just going to be x minus 5 and x plus 4. Okay, so if I write this down here, x minus 5, x plus 4 is equal to 0. I have two brackets here that need to multiply to give me 0. So that means either the first bracket has to equal 0 or the second bracket has to equal 0. Now using this, I can solve for x. X must equal positive 5 and x is equal to negative 4. A trick to this is whatever you have inside the bracket, your answer is the opposite. So x minus 5, the answer must be x is equal to positive 5, and with x plus 4, the answer must be x is equal to negative 4. And we are going to solve 7 over x minus 3 plus 10 over x plus 1 is equal to 3. So the first thing is we need to get rid of the denominators. So in order to get rid of the x minus 3 in the first fraction, I'm going to multiply everything by x minus 3. And I'm going to do that to the second fraction, and I'm going to do that to the 3 on the end. And then what I'm going to look at is getting rid of the x plus 1. So I'm going to multiply this by x plus 1. I'm going to multiply this term by x plus 1 and the final one by x plus 1 as well. Okay, so I think before what I did was I broke that step down. This time I'm just doing it straight. So the first bracket, hopefully you can see that the x minus 3 will cancel, and I'm going to be left with just the 7 brackets x plus 1. And in the second fraction, hopefully you can see I'm cancelling out the x plus 1s, and I'm left with 10 bracket x minus 3, and that's going to be equal to the 3 brackets x minus 3 x plus 1. I'm just going to expand the first two brackets, so it's 3x minus 9, and I'm going to be left with x plus 1. Okay, at this point I'm just going to tidy things up. So on the left hand side, 7 brackets x plus 1 is going to become 7x plus 7, and the second bracket is 10x minus 30, and that's going to equal the expansion of 3x minus 9 and x plus 1. So I'm going to use the single bracket method, so that's 3x times by x plus 1. And then the second term, which is negative 9, times by the second bracket, x plus 1. Okay, if you want a tutorial on how to do that, please let me know and I'll go through it in a bit more depth. Otherwise, I'm going to assume that you know how to do that. Or you can use the grid method, you can use the beak method, whatever floats your boat. I'm not too fussed, just as long as you get the right answer. So if I expand the right side of the equation, I've got 3x squared plus 3x minus 9x minus 9. Okay, I'll leave it like that for now. I'll tidy it up in a second. On the left hand side, I'm just going to gather the like terms. So I've got 7x and 10x, which is 17x. Then I've got 7 minus 30. So that's going to be minus 23. This can tidy up and be 3x squared. So the 3x and then minus 9x is going to give me minus 6x minus 9. And then I've got 17x minus 23. So in order to get rid of that, again, I'm going to just do it in one go. I'm going to get rid of minus 17x on both sides. And I am also going to plus 23 on both sides. You can, show each of these individual steps. I'm just breaking it down. I say breaking it down. I'm doing the opposite of breaking it down. I'm just doing it in one go to save a bit of time. So I've got this side is obviously going to equal to 0. I've got 3x squared, which is unaffected. So I've got negative 6x minus 17x, which is minus 23x. And then minus 9 plus 23 is positive 14. So I'll leave it like that. At this point, I'm going to do some work on the right hand side just to make a bit of space. I am going to solve 3x squared minus 23x plus 14. Hopefully you should realize because the coefficient of x squared, so that means the number before x squared is bigger than 1, I have to use the AC method. So that means I need, if this is ax squared plus bx plus c, I need to multiply a by c. So a by c is equal to 3 times by 14, which is, if I'm not mistaken, 42. I need 2 factors of 42 that are going to give me negative 23. 42 is 42 and 1, or 21 and 2. 21 and 2 will make 23. Yeah, so 21 and 2, how can I make 23? So 42 needs to be positive. That means both of these must be negative, and that works. So that means this initial, let's just bring it here. I can split up the 23x into minus 21x and minus 2x. Okay, and then obviously just bring down that 3x squared and bring down that 14. And I'm just going to split the 4 terms down the middle, and I'm going to factorize the left hand side and the right hand side. So remember to take out the highest common factor, otherwise this will not work. The highest common factor of 3x squared minus 21x is 3x, so I can take out from both. Inside the bracket then I'm going to be left with x minus 7, and that should repeat on the other side, but I'm just going to double check. What can I take out from negative 2x plus 14? Well, I can take out a negative 2, because that will help me get that x minus 7 inside the bracket. Hopefully that makes sense. Keep that in shot. Now I'm just going to combine both of these brackets. So the 3x minus 2 is going to be combined, and I'm just going to do it down here. So 3x minus 2 is one bracket, and then the x minus 7, which is the repeated bracket, is the second bracket. And remember, I'm solving, so I have to make it equal to 0. I'm just going to write it up here. Again, so that means either 3x minus 2 is equal to 0 or x minus 7 is equal to 0. Okay, so if we take the first one, that means 3x is equal to 2, x must be equal to 2 over 3, or 2/3. And then for the next one, x minus 7 is equal to 0, so that means x is equal to 7. Plug them back in if you really want to double check if your answer is correct. It should equal the original question. So that's 7 over x minus 3 plus 10 over x plus 1 should equal 3. If you plug in x is equal to 2/3 or x is equal to 7. Obviously, if it doesn't work, you've gone wrong somewhere. Usually, if that's the case, then you've messed up with one of your negatives or slight expansion, or maybe you've just got your factors wrong when you've done the AC method, etc. So please let me know if you have any questions in the comment section, or if you'd like me to go over the AC method or expansion in general, etc. Okay, so hopefully I can try and help you. Okay, so this question looks really complicated, but it isn't. We're just going to follow the simple concept of factorize everything and simplify before I attempt the rest of the question. If we take the numerator in the first fraction, I can factorize out a 2, so I'm left with 2 brackets x plus 3 over x minus 3. Now I can't simplify anything or cancel anything out, so I can leave that. Then I've got the division, and now I'm going to deal with the second fraction, and I'm going to deal with the denominator first because I can see it's a difference of 2 squares. If it's a difference of 2 squares, that means I need to square root x squared, which is simply x times x. I need to square root 9, which is 3 and 3. The only way to get a negative in the middle is if I'm multiplying a positive number, so that must be a plus, by a negative number, so this must be a negative. So that's my denominator dealt with. Now, if I'm trying to deal with this numerator here, so I'll just color that in orange so you can see which numerator I'm talking about. I need to apply the AC method because the coefficient of x squared is greater than 2. So I'm going to do 2 times 3, which is 6. So I'm trying to find factors of 6 that are going to add to give me positive 7. So off the top of my head, it must be 1 and 6. And that means I'm going to take my numerator, which is 2x squared plus 7x plus 3, and I'm going to separate the x term into 1x, or just x, and 6x. And I can just bring down the 2x squared, and I can bring down the positive 3 at the end. Now I'm just going to split this down the middle, and I'm going to factorize the 2 terms on the left, and then the 2 terms on the right. So 2x squared plus x, the only thing I can take out is an x term. I'm going to be left with 2x plus 1 inside. Now this bracket should repeat, but I can double check that. 6x plus 3, I can only factorize out a positive 3. And inside the bracket, I'm going to be left with 2x plus 1 as expected. Okay, now I'm going to combine my coefficients of the bracket. So I've got x plus 3. That's going to form one bracket. And now my repeated bracket is going to form the second bracket. So I've got x plus 3, 2x plus 1. Remember, this is my numerator, so I'm just going to bring it back up here now. So I've got x plus 3, and I've got 2x plus 1. Now, hopefully you can see there's a few things I can cancel out here. So I can cancel out the x plus 3 and the x plus 3. I'm going to be left with the initial fraction, which is 2 brackets x plus 3 over x minus 3. I'm going to change my sign into a multiply, and then I'm going to flip my final fraction. So I'm going to change, and I'm going to flip the 2x plus 1 over x minus 3 into x minus 3 over 2x plus 1. Now, when you're multiplying fractions, all you've got to do is multiply the numerator and multiply the denominator. So I've just got to bring this together. So I've got 2 brackets x plus 3 multiplied by x minus 3 over x minus 3 brackets 2x plus 1. Hopefully at this stage you can see that x minus 3 is going to cancel in the numerator and denominator, and I'm just left with 2 brackets x plus 3 over 2x plus 1. Double check that I can't simplify any further, so the numerator is fully simplified, fully factorized even, and the denominator is fully factorized as well, so I'm going to stop there. In this question, we are going to be dealing with equivalent ratios. Now, I want you to consider 1 to 2 and an equivalent ratio. So I'm just going to use 2 to 4. We can write this ratio as 1 over 2, and write this ratio as 2/4. Now, hopefully, you should recognize that 2/4 is equivalent to 1/2 anyway. So we are going to apply this concept to our ratios. Another thing that is true that you might want to be aware of is you can also write this ratio as the 2/1 and make that equal to 4/2. 2 divided by 1 is 2. 4 divided by 2 is also 2. Okay, you've just got to be careful that if you are making your first ratio the numerator, then on the right hand side, the first ratio also has to be the numerator. Okay, and vice versa with the denominator. Using that concept, what I'm going to do is I'm going to take this 2x plus 1 and make it over the x plus 2. So I'm going to do 2x plus 1 over x plus 2. And I'm going to make it equal to, sometimes they use the word equivalent, by the way. So if you see, they say this ratio is equivalent to that ratio, just make them equal to each other. And coming back, I'm going to make the first one the numerator and the second ratio the denominator. So I've got x plus 8 over 3x minus 4. And that's all you have to do. Now you can solve these algebraic fractions by first getting rid of the denominators. So I'm just going to cross multiply. I'm going to end up with 2x plus 1 brackets 3x minus 4. And that's going to equal x plus 8 brackets x plus 2. I'm going to expand the left hand side. So I've got 2x brackets 3x minus 4 times by positive 1. Add positive 1 brackets 3x minus 4, which is equal to x brackets x plus 2 plus 8 brackets x plus 2. And now I'm just going to expand as I normally would. So that's going to end up being 6x squared minus 8x plus 3x minus 4 is equal to x squared plus 2x plus 8x plus 16. I'm going to tidy up both sides. So the left hand side is going to be 6x squared minus 5x minus 4. On the right hand side, I'm going to have x squared plus 10x plus 16. And now I can just gather the like terms, make one side equal to 0, and then solve this quadratic. So because this 6x squared is positive, if I bring the x squared over, it's going to remain positive. So I'm just going to subtract x squared from both sides. Then I'm going to subtract 10x from both sides. And then finally, I am going to subtract 16. So I'm just doing it in one go. If you want to do it individually, you can do. 6x squared take away x squared is going to be 5x squared. Negative 5x minus 10x is negative 15x. Negative 4 minus 16 is minus 20. And obviously everything on the right hand side is just cancelled, so it should be equal to 0. Now you should notice that all of these terms are divisible by 5. So 5x squared becomes x squared, minus 15x divided by 5 is 3x, minus 20 divided by 5 is minus 4. That equals 0. And now I am going to solve this. I'm just going to make a bit of space for myself. Two numbers that multiply to give me negative 4, but add to give me negative 3. It must be 4 and 1 somehow, and the only way it would be negative 4 and positive 1. That means in my double bracket, I'm going to have x minus 4 multiplied by x plus 1. And that equals 0. Okay, I've just run out of space there, so I'm just going to move this up here. And I'm going to solve x minus 4 is equal to 0, which means x must equal positive 4, and x plus 1 is equal to 0, so x must equal negative 1. And they are my two solutions. Thank you for watching. This has been Mr Miah at R Squared Tuition. Don't forget to like and subscribe, turn on notifications, and comment below any questions or topics that you would like me to cover.